Good day, students. Welcome to part 2 of the installment of on how to factor trinomials by grouping. I recommend that you go over part 1 of this video series before you go over these examples I'm going over here. All right, there are going to be 3 parts. We're going to start really easy. I started really easy in part 1. This was slightly more complicated, and then we'll have the full-blown problems in part 3. All right. So let's write down instructions for these examples I'm going to do. So factor um, the following expressions by grouping. Okay. All right. So let's take a look at number 1. Number 1, what if we had the expression 3x squared plus 21x plus 2x plus 14. So how do we factor this? So what we need to do here is basically we just break it down the center, the first two and then the last two, break it in front of the sign right here. And then what I'm going to do is I'm going to break down each term and then I'm going to factor by grouping, okay? So for the first one, for the first term, I'm going to break it down into 3 times x plus, and then what does 21 break down into? If you use your factor tree, is 7 times 3, right? That goes your factor tree, so 7 times 3 times x plus, and then on this side 2 times x plus, and then you break down 14. 14 is 7 times 2 if you break it down using your factor tree. Alright, so let's take a look at the left side of my partition right here. What's common? If you notice, 3 and 3 are common on both sides of this plus, and you also have x and x, they're both common. Alright, so what am I going to do? I'm going to factor them out. Alright, remember we talked about this before. Whenever you're factoring, it is as though you're dividing. So when I factor out 3x, this 3x, this 3 and this 3 are factored out here as though I divided them by 3. And then this x and this x are factored out here. Okay, and what are you left with? You're left with x plus 7. Okay, so what you're left with in the parentheses is x plus 7. Alright, so remember, anytime you factor out anything, it's as though you were dividing. So since I factored out 3x is as though I was dividing by 3 right here, 3x right here, and then 3x right here. That's why I have a 3x on the outside, and that's why you cancel out. And then I'm just left with x plus 7 down here. Okay? So I'm going to do the same process on the right side of the partition. I'm going to factor out 2 and 2, which are common. Bring it down before you cancel it. So because after I factor it out, this and this are gone because they're common. Alright? And I'm left with x plus 7. Alright? So I have x plus 7 here. Now to check to see if our factorization is correct, you see these quantities in parentheses, they're the same, right? So I can factor both of them together as 1. So I'll factor this, x plus 7 and x plus 7, both of them will factor into 1, just like I did in part 1 of the video, x plus 7. And what are you left with? You're left with 3x and positive 2. What do you do with those two? You bring them together into parentheses x. I'm sorry, 3x plus 2. Alright, 3x plus 2. And there goes your factored form. Voila. Okay? Alright, now we're going to try another example. Alright, so for number 2, write down the following. We're going to factor, so let's see, for number 2, we're going to do n squared plus 4n plus 4n plus 16. Alright, so since we have 4 terms here, we want to factor by grouping. What we'll do is break it down the center in front of this sign right here, okay? So we're going to break down each term, the left side and the right side, and factor out common factors. Alright, so let's break it down first so it's easy to pull out the common factors. N squared can be broken down into n times n plus, if you break down 4 with your factor tree, is just 2 times 2. So it's going to be plus 2 times n. And then the 4, same story, 2 times 2 times n. And then if you break down 16 using a factor tree, is 2 times 8, 2 times 4, and then 2 times 2. So it's 1, 2, 3, 4, 4, 2. So 2 times 2 times 2 times 2. Okay? Alright, so let's focus on the first two on the left side of our partition. What's common? You notice that uh, n is common. Okay? So n and n are common. So what am I going to do? I'm going to factor them out, right? Remember, whenever you're factoring stuff out, is as though you're dividing. So if I factor out n, this n and this n are gone because they've already been factored out, and I'm going to be left with, what am I going to be left with? I'm going to be left with n, and these two 2's right here, which multiply together to give you 4. So you're going to be left with n plus 2 times 2, which is 4. Alright, now on this side, just always bring down the sign plus. If it's minus, you bring it down and switch the sign. Okay, so since it's plus, there's no sign inversions going on here. So what is common? Let's see. 2 and 2. Two 2's are common, alright? So if you factor out 2 2's, 2 times 2 is 4. So we can factor 2 times 2 as 4 outside. That means that these 2 2's and those 2 2's are gone because they've already been factored out. So what are you left with? You're left with n, and then these 2 2's here. Alright, so we bring down the n with the sign plus. 2 times 2 is 4. Alright, now let's look at what we just created. These are similar to the problems that we did in part 1 of this video series, right? So let's factor these by grouping again. So we see n plus 4 and n plus 4 are common on both sides. So what do? I factor them out as well as dividing. So I have n plus 4 as a factored out factor because it's common. And what am I left with after factoring out n plus 4? I'm going to be left with n and positive 4. So I'm just going to write out over here n plus 4. Now if you examine your answer, you notice that these two quantities are the same, so they can condense further into n plus 4 quantity squared. And there goes your final result. Okay. Now next, we're going to try an example where we have a minus in the center that has some kind of, it's somewhat technical, so we've got to be really careful whenever we have minuses right at the center, okay? So let's try an example of that nature, number 3. Let's say we're doing 10z squared minus 15z minus 4z plus 6. Alright, so what I'll do is I'll partition it down the center in front of the sign, and then we're going to start factoring by grouping, okay? So I'm going to break down each single term, and then we'll pull out common factors. So let's break down 10. What does 10 break down into? If you use your factor tree, is just 2 times 5. So 10 breaks down into 2 times 5 times z, because you have z squared, minus 15 breaks down into 3 times 5, right? Using a factor tree. So it's going to be 3 times 5 times z. Now let's go over here. You're going to bring down a minus. Break down 4. 4 is 2 times z. And then when you break down 6, 6 is 2 times 3. Okay? Now let's start factoring. On the left side of our partition, we're going to factor out whatever is common. So what's common there? We can see that 5 and z, 5z is common on both sides of on the left side of my partition. Okay, so those two will get factored out. So I'm going to bring down 5z. So after factoring out 5z, these two are gone because it's as though I divided the top term by this factor I just pulled out. So what are you going to be left with? You're going to be left with 2z on the left side of the minus, and then negative 3 on the right side. Okay? I mean 2 on the right side. So it's going to become 2z minus 3. Okay? Now, here's where you want to be really careful. When I bring down a minus, I'm going to factor out a minus. Okay? Anytime you factor out a minus, the center sign changes because minus divided by a plus is minus. Alright? Okay, so what can I factor here? I can factor out 2 and a 2 because it would come. Alright? So if I factor out 2 from both sides, what am I going to be left with? Well, let me put down the 2 down first. So because I factored out the 2, that means this 2 and this 2 are gone. And you're going to be left with 2z and positive 3. Alright, so your answer is going to be 2z. Oh wait, since you took out a minus from a plus, you're left with a minus, minus 3, okay? Note, minus times minus is plus. That's why minus divided by plus is minus. And also, these two signs have to match. If they don't match, then that means you're wrong. Alright? So let's now look at this result that looks like the problems we were doing in the previous part of this video series. So what is common here? You notice that 2z minus 3 and 2z minus 3 are common on both sides. So what can I do since they're both common? Factor them out, right? So you factor them into 2z minus 3. And what are you going to be left with? You're going to be left with 5z, put that in the parentheses, 5z minus 2, minus 2. Now, there goes your final answer. Alright? So you got to be really careful whenever you have a minus in the center right here, because this sign gets to get inverted and then it changes the problem a little bit. Okay, let's try another example where you have a minus in the center and then see if we can get it correct. Okay, so in this one we're going to try, what number are we on? Number 4. So number 4 we're going to try 24 x squared minus 16x minus 27x plus 18. Alright, so what I'm going to do first is factor by grouping. Since we have 4 terms, I'll break it down the center, alright? Now, let's break each factor down, each pair down, and see what we can pull out. Alright, let's break down 24 using my factor tree. I take out 2, 2 times 24, 2 divided by 24 is 12, take another 2, 6, 2, 3. Alright, so that goes the factored form of 24. So we're going to have 2 times 2 times 2 times 3 times x minus. How about 16? I take out 2. Remember, I'm pulling out prime factors, okay? I'm doing the prime factor decomposition. So 2 goes into 16, 8, 2 goes into 8, 4, 2 goes into 4, 2. So 4 2's is the prime factor decomposition of x 16. 16. So you're going to have 2, 2, 2, 2 times x. Let me shoot this. Let me shoot that a little bit. Is it right? That. Alright, and then put in the x times x times x. Alright. On the right side minus, what does 27 break down into? I can take out 3 from 27, left with 9, and then 3 and 3. So 3 times 3 times 3, so it's 3 times 3 times 3 times x. And then let's break down 18. I can take out 2 from 18, I get 9. Take out 3, 3. So 2 times 3 times 3. So plus 2 times 3 times 3. There you have it. Okay, now let's look at the first two. What can I factor out? So I can, let's see, I have 1, 2, 3 2's here. So I can take out 3 2's. And then here I can also take out 3 2's. And I can also take out an x, and I can also take out an x right here. Alright? So what is 2 times 2 times 2? 2 to the third power is 8, right? So you're going to have 8x factored out. Alright, so that means this is gone, and that is gone. These 3 2's are gone, and that's gone. So what do you have left? You're going to be left with 3 minus, 3x minus 2. Alright, so you're going to have 3, this one and this one, 3x minus this 2 right here, minus 2. Okay? Alright, let's switch to this side. Hopefully we have 3x minus 2 in the parentheses when we're done factoring. Bring down the minus. Notice we're factoring out a minus here. What is common on both sides? We can factor out, let's see, we can factor out 2 3's on the left side here and 2 3's on the right side here. Okay, so if I factor out 2 3's, it comes out as 9. Alright, so if I factor out those common factors, what do I have left? Parentheses, I'm left with 3x. Now since I factored out a minus from a plus, this sign switches to a minus 2. Okay, so be careful with that. So you notice that this quantity and this quantity are both the same, which is excellent. Alright, so now let's factor out again by grouping. What's common? 3x minus 2 and 3x minus 2 are both common. So I'm going to factor them out as 1. 3x minus 2. So if I factor them out, it's as though I divided both sides by that. So that means they're gone. So what do I have left? I have 8x minus 9. So 8x minus 9 and there goes your fractal form. Okay? Alright, thank you so much for paying attention to this presentation. Uh, Please subscribe to my channels so that you can get the more videos to deepen your understanding of mathematics. And if you like this video, please click down here to like it. If you didn't like it, you can email me or put a comment, and I'll be glad to address whatever your concerns are. You can find more of my videos on mathwithsir.com. Thanks again, and have a wonderful day.